Everybody dreams about traveling at the speed of light. Movies portray it as the ultimate freedom, the final frontier, the key that unlocks the stars. Scientists spend careers calculating it. Engineers dream of building it. Children stare at the night sky and wonder what it would feel like to just go. But here's what no one tells you. According to modern physics, if you somehow survived traveling at light speed, it would instantly become the worst decision of your entire existence. Not because of the danger, not because of the distance, but because of what light speed does to reality itself. Because the moment you reach that velocity, time begins breaking. Space becomes hostile. The universe starts attacking you, and worst of all, you may never truly come home again. Here are 5 brutal reasons you would instantly regret traveling at the speed of light. Reason 5. You would never actually reach light speed. Let's start with the most infuriating part of this entire dream. You can't get there. I don't mean it's difficult. I don't mean it's expensive, or that the technology doesn't exist yet. I mean that according to the laws of physics as we currently understand them, it is fundamentally, mathematically, absolutely impossible for anything with mass to reach the speed of light. Here's why. In 1905, Albert Einstein published his special theory of relativity. And buried inside that paper was a discovery that shattered every intuition humans had about motion and speed. As an object moves faster, it doesn't just move faster. It gets heavier. Not physically heavier, not in a way you'd feel, but in terms of what physicists call relativistic mass, the effective resistance an object has to further acceleration. The faster you go, the harder it becomes to go faster. At 10%, the speed of light, this effect is almost invisible. Your ship is only slightly heavier than it was at rest. The engines barely notice. At 90%, the speed of light, it starts becoming significant. You need dramatically more energy to accelerate even a tiny bit more. At 99% the speed of light, you need staggering amounts of energy just to push the needle slightly further. At 99.9%, the energy required becomes absurd. At 99.9999%, you're already consuming more energy than some stars produce in their lifetimes. And the final 0.0001% question mark. The mathematics says you would need infinite energy to cover that gap. Infinite. Not a lot. Not more than we can currently generate. Infinite. An amount that doesn't exist in the universe. Imagine humanity spending centuries building the ultimate ship, a vessel the size of a city, engines that harness the power of nuclear fusion, antimatter annihilation, or technologies we haven't even invented yet. The crew boards. The countdown begins. The engines ignite. Velocity climbs. 50% light speed. The stars begin to shift. 90% light speed. The crew feels the cosmos changing around them. 99% light speed. The instruments scream with energy expenditure unlike anything in human history. 99.9%. Every atom of fuel the ship carries is burning. 99.999%. The engines are giving everything they have, and then nothing. The gap doesn't close. The finish line retreats forever like a horizon that moves away the closer you approach. No matter how much energy you add, that final fraction of a percent remains untouched. You spent everything. You got almost nowhere. The 5th reason you regret traveling at light speed is that physics never lets you get there. Reason 4. Space turns into a shooting gallery. Let's say you somehow bypass the energy problem. Let's say you've discovered some exotic workaround, some loophole in physics we don't yet understand. You're now traveling at 99.99% the speed of light. Congratulations. You have just entered one of the most hostile environments imaginable, and the hazards are almost completely invisible. Here's a fact most people don't appreciate. Space is not empty. It looks empty. When you stare into the night sky, you see darkness between the stars, but that darkness contains matter, dust, microscopic debris, remnants of ancient stars, and most importantly of all, hydrogen. Just hydrogen atoms drifting through interstellar space. One proton, one electron, tiny, lightweight, completely insignificant at the speeds humanity has achieved so far. At near light speed, they become something entirely different. When you're traveling at 99.99% the speed of light, every particle encountered carries extraordinary relative energy. The physics becomes brutal. A single hydrogen atom impacting your ship behaves less like ordinary matter and more like an ultra-high energy particle collision. Multiply that by the countless particles encountered every second, and suddenly your spacecraft isn't gliding through empty space. It's moving through a constant storm of extreme energy impacts. Physicists sometimes discuss a phenomenon nicknamed the blue wall. As velocity approaches light speed, radiation ahead becomes increasingly compressed through the Doppler effect. What began as relatively harmless wavelengths can shift toward energetic X-rays and gamma rays, creating a continuous stream of intense radiation striking the front of the vehicle. You're no longer simply traveling through space. You're forcing your way through a region where the universe itself begins concentrating energy directly into your path. And that's only the hydrogen. What about dust grains, micrometeoroids, tiny fragments of rock drifting between the stars? At ordinary spacecraft velocities, a grain of dust might leave a minor mark on a hull. At relativistic speeds, the story changes dramatically. Even microscopic particles can release enormous amounts of energy upon impact. Objects that would normally be insignificant become major engineering threats. Shielding systems must withstand energies comparable to events normally associated with the most powerful technologies humanity has ever built. Think about that. Not an asteroid, not a mountain-sized object, a tiny grain of dust, something almost invisible. At near light speed, it becomes a serious survivability challenge, and interstellar space contains vast numbers of them. Every kilometer of the journey contains potential collisions that physics amplifies into major hazards. The universe doesn't need giant obstacles to stop you. At relativistic speeds, even the smallest particle become formidable. Reason 3. The universe stops looking real. Let's assume you've solved the energy problem. Let's assume your shielding can survive the radiation. Let's assume your spacecraft remains operational despite the particle storm. You're now cruising through the cosmos at near light speed. Then you look outside, and reality begins behaving in ways your brain was never designed to process. What you would see is so strange, so counterintuitive, that it barely resembles the universe we experience every day. Here's why. At normal speeds, stars surround you in every direction. Behind you lies the galaxy you left. Ahead lies the galaxy you're approaching. To either side stretches the full panorama of the cosmos, a vast sphere containing billions of points of light. But as you accelerate toward light speed, something extraordinary happens. The stars ahead begin compressing toward the center of your vision. A phenomenon known as relativistic aberration starts bending your visual perspective inward, almost as if the entire universe is being squeezed through a cosmic fisheye lens. By 90% of light speed, stars that should appear far to your left and right begin shifting noticeably forward. By 99% of light speed, the effect becomes extreme. Nearly all visible light in the universe appears concentrated into a bright region directly ahead of you. The cosmos no longer surrounds you. It gathers in front of you, behind you, darkness. Not because the stars vanished, not because the universe disappeared, but because the geometry of space-time itself has transformed your view of reality. The familiar night sky is gone. In its place is something profoundly alien, a universe distorted by velocity, compressed by relativity, and reshaped by the fundamental laws of physics. At that point, the challenge is no longer just engineering. It's understanding what you're actually looking at. Because the light from those stars can no longer catch up to you. Ahead, a tiny disk of compressed, blinding, rainbow-shifting chaos. And that's not even the worst part. The colors are wrong. Because of the Doppler effect, light from stars ahead of you gets compressed and blue-shifted. Normal starlight becomes ultraviolet. Ultraviolet becomes X-rays. X-rays become gamma radiation. The light itself is no longer visible. It's shifted beyond what human eyes can detect. Meanwhile, light from stars that should be visible to your sides has been red-shifted so severely it's dropped below infrared, below radio waves, gone from visible reality entirely. The universe has transformed from a breathtaking panorama of billions of stars into a strange, shimmering, unrecognizable tunnel. Colors you can't name, shapes that don't match any constellation ever mapped. Humans are not built for this. We evolved to understand a world with up and down, with distance and proximity, with a sky that looks roughly the same wherever we stand on Earth. Our sense of reality is built on visual cues that light speed travel destroys entirely. Multiple physicists who have studied relativistic travel have noted that the psychological impact alone might be debilitating. Disorientation so complete that the crew might not be able to function. You wanted to explore the universe. Instead, you watched it disappear. Reason 2. Everyone you love dies. Now we arrive at the reason that stops people cold, the one that makes the physics personal: time dilation. Einstein's special theory of relativity contains a prediction that feels like something from a horror story. The faster you move relative to someone else, the slower your personal clock ticks compared to theirs. This isn't a theory waiting to be confirmed. We've measured it. Every GPS satellite in orbit has to correct for this effect constantly. They tick slightly faster than clocks on Earth because of both their orbital speed and their distance from Earth's gravity well. Time dilation is real. It is tested. It is proven. And at near light speed, it becomes catastrophic for everyone you've ever loved. Here's the math. At 99% the speed of light, time on your ship passes at roughly 1/7 the rate of time on Earth. For every 7 years that pass on Earth, you experience only 1 year. At 99.9% the speed of light, that ratio becomes roughly 1 to 22. 1 year for you, 22 years on Earth. At 99.9999% the speed of light, we're talking about 1 year for you, over 700 years on Earth. Let's make this concrete. You volunteer for a mission to a star 40 light years away. To you, the journey takes roughly a year each way, 2 years total, maybe a bit more with acceleration and deceleration. You pack 2 years worth of supplies. You say goodbye to your family. Your parents are in their 60s. Your children are young. Your friends promise to keep in touch. You leave. 2 years pass. You arrive, study the target star system, make the return journey. You spend the whole trip thinking about getting home, and then you land, and nothing is right. The spaceport doesn't look like you remember. The city beyond is different, taller, changed. You try to contact your family. The communication network has a different interface. The protocols have changed. You manage to reach a database, a public historical archive. You search for your family name, and you find them. Not in a contact list, not in a phone directory, in a genealogy record, dated over 1,000 years ago. Your children lived full lives. They had children of their own, grandchildren, great-grandchildren. Generation after generation that grew, aged, and was forgotten while you were away for 2 years. Your son, who was 7 when you left, lived to his late 70s and died over 1,300 years ago. Your daughter outlived him by a decade. Their children had children, and their children had children. And eventually, after dozens of generations, the family name faded from history entirely. You are not in anyone's memory. You are in a footnote. The 2 years you spent on that ship were 2 years to you, but Earth experienced over 1,400 years. The world you left doesn't exist. Your family, in any meaningful sense, doesn't exist. Everything you loved, everything you built your life around, everything that made the mission worth doing in the first place, gone. Imagine saying goodbye to the people you love, experiencing only 2 years of your own time, and returning to find their names carved into gravestones so old the stone itself has crumbled to dust. Their photographs behind museum glass. Their stories reduced to 3 lines in a history archive that nobody reads anymore. You survived the journey, but everyone else didn't. Reason 1, you become a ghost of time. Because what we just described was only a moderate relativistic speed. 2 years away, 1,400 years lost. But what about pushing to the absolute theoretical limit? At velocities even closer to light speed, the Lorentz factor approaches infinity. That means the ratio of ship time to Earth time doesn't just become extreme, it becomes incomprehensible. At sufficiently extreme velocities, you could complete a journey and return to Earth having aged only a few months, while Earth experiences thousands of years, 10,000 years, 100,000 years, more. Human civilization, as it exists right now, has only been around for roughly 10,000 years. The oldest cities on Earth are 6,000 years old. Written language is 5,000 years old. In 100,000 years, human civilization could rise and fall dozens of times over. Your species could evolve into something you wouldn't recognize. Nuclear war could have erased everything. Or some breakthrough could have transformed humanity into something transcendent. A civilization so advanced it might not even remember you as anything more than a primitive ancestor. You come back. Earth is still there. Maybe. But when you step off the ship, no one knows your name. Your language doesn't exist. The culture you came from is so ancient, it's archaeology. The technology you used to build your ship is so primitive, it belongs in a museum next to stone tools and bronze swords. You are not a returning explorer, you are a ghost. You belong to an era so far in the past that it might as well be prehistoric. You did not travel through space. You traveled beyond your own civilization. You have no home, no era, no people, no place in history. Not because you died, but because you moved so fast that everyone and everything you were part of simply ran out of time and left you behind. Humanity dreams about reaching the stars. We've dreamed about it since the first human looked up at the night sky and wondered what those lights were. Since the first astronomer mapped the heavens. Since the first rocket left the atmosphere and didn't come back. But speed was never the real obstacle. The real obstacle was time. Because the closer you get to the speed of light, the further you drift from everything that made you human. The connections, the history, the people, the world you built your identity around. The stars may eventually belong to us. The physics might bend. New discoveries might emerge. Wormholes, warp drives, technologies we can't yet imagine might one day close the gap between here and there. But by the time we reach them at near light speed, the people who began the journey will already be gone. Not dead, but displaced. Separated from their world by a gulf of time no distance could ever measure. And that is the cruelest trick the universe ever played. It allows you to outrun distance. but never loss.